In number 1, we want to find the n behavior. So the n behavior depends on the highest term, the highest order term, that is the term with the highest exponent. If we were to multiply this out, the first term would have a coefficient of -4. We would have the highest power from here is x to the 5th, and that would be multiplied by the highest power from here, which would be x squared. So so that would be -4x to the 7th plus lower terms, or terms with smaller exponents. So this would be the highest exponent. And the n behavior will depend only on this term. So we say as x goes to infinity, what happens to -4x to the 7th? So this is getting larger and larger, and we have this negative in front, so this is going to go to negative infinity. And as x goes to negative infinity, the same leading term, well, this goes to infinity. Sorry, this goes to negative infinity. Okay, x is going to negative infinity, and this is odd. Notice this is odd. So this is going to negative infinity, and we have the negative in front, so that would be 2 negatives, so that would be positive infinity. Right, and number 2, let's find the leading term again. So here we have an x squared coming out of this first factor, and that's going to multiply an x to the 6th coming from the second factor. So the leading term is x to the 8th plus other terms that are lower, have lower exponents. So we say as x goes to infinity, x to the 8th goes to infinity. And as x goes to minus infinity, x to the 8th still goes to positive infinity. And that is because of this even exponent. So that's the n behavior. It's going to be up on the right and up on the left. Number 3, we want to find the real zeros, which is the same as x-intercepts. So basically we set y equal to 0, or set this equal to 0 and solve. So we have 0 equal x cubed minus 25x. This is easy to factor, so we'll just pull out an x, and we get x times x squared minus 25, and then we'll factor this x squared minus 25. It's a difference of 2 squares, so that would be x plus 5 times x minus 5. All right, so now it's completely factored, so we can set each factor equal to 0 to get the x-intercepts. Well, from the first factor we have x equals 0. From the second factor we have x is equal to negative 5. And from the third factor we have x is equal to 5. Okay, a polynomial of degree n has at most n x-intercepts. All right, like if we have a polynomial of degree 2, for example, let's say we have, here's a polynomial of degree 2, x squared minus 5x plus 6. This is degree 2. And if we factor this, we have x minus 3x minus 2. So we see it has 2 x-intercepts, 3 and 2. Degree 2, 2 x-intercepts. And in general, a polynomial of degree n has at most n. And how many turning points? Well, let's go back to this example. This is a quadratic, or sometimes we call it a parabola, and basically the graph looks like this. 1 turning point. Degree 2, 1 turning point. Here's the turning point is the vertex. So 1 less than the degree, and that works for all polynomials, all degrees. The polynomial of degree n has at most n minus 1 turning points. In number 5, let's look at this polynomial. It's already factored, so it's easy to find the zeros. Let me just copy this over. From each factor, we get a zero of the polynomial. So from x to the fourth, we have the 0, x equals 0. All right, from the second factor, we have the 0, x equal negative 5. And from the third, we have x equal 2. All right, obviously we get these by setting each factor equal to 0. Now for the multiplicities, that would just be given by the exponent. So x equals 0 has multiplicity 4. X plus 5 has multiplicity 1. Sorry, that is x equals 0 has multiplicity 4, x equal minus 5 has multiplicity 1, x equal 2 has multiplicity 3. All right, number 6, we want to do a plus-minus analysis of this polynomial. So we're going to put the zeros of the polynomial on the number line. So here we have x equals 0 coming from this first factor. We have minus 4 coming from the second factor. And we have 3 coming from the third factor. So we put the zeros on the number line in order, smallest to biggest. And then we look at values in between the zeros. Now, since x plus 4 has multiplicity 2, and 2 is even, then let me just put a star next to the 0 minus 4, because we expect the sign to not change when we go from one side of minus 4 to the other. That's because of this exponent 2. All right, so let's start by substituting in a value larger than 3, like 4, for example. And if we do that, here we have negative 4. This is positive. And here we have 4 minus 3, which is positive. So we get something negative. If we substitute in 1, here we have minus 1. This is positive because it's squared. And here we have 1 minus 3, 2 negatives, and that would be positive. All right, so we have this alternating pattern. To the left of 0, let's say we substitute in minus 1. Then this would be positive, minus 1. So we have positive. This is always positive. And here we have minus 1 minus 3 is negative. So we have positive times a negative, so that would be negative. We expect a negative here as well because of that multiplicity 2. Let's say if we put in, let's just confirm that, if we substitute in a minus 5, this would be positive. This is always positive. And minus 5 minus 3 is negative. So, all right, so we have the alternating pattern broke when we went from one side of minus 4 to the other. So here's the plus-minus analysis. Number 7, we want to graph. All right, so we'll start by putting the zeros on the number line. So on the number line, we're going to put x equals 3. X equal minus 1. Okay, that's 3, minus 1, and let me change this. This is, let me change this. I don't want another 3 here. Let me change it to x minus 5. Okay, so here we have 5. So these are our zeros. Now notice this one, x equals 3, is multiplicity 2. So let me just put a little circle around here just to remind ourselves that over here the graph is not going to pass through the x-axis. It's going to stay on one side or the other. Okay, it's just going to touch the x-axis because of that multiplicity 2. All right, what about the end behavior? Well, we have for the first term of this polynomial, if we were to multiply this out, the first term would be 2. From here we'd have an x squared. From here we'd have an x, and from here we'd have an x. So that's 2x to the fourth would be the highest term, the term with the highest degree. So 2x to the fourth, as x goes to infinity, would go to infinity. I'm just going to indicate that on the graph, and as x goes to minus infinity, it would also go to positive infinity. So we expect the graph to go up on the right and up on the left, so I'm indicating that. All right, now we're actually ready to graph. Maybe we should first find the y-intercept. That would be good. So the y-intercept, we're going to set x equals 0, and we get y is equal to 2 minus 3 squared from that second factor. 1, we're setting x equals 0, so that would be 1. And here we have a minus 5. All right, so let's work that out. So we have 2 times 9 times minus 5, which is, sorry, it's minus 5. So that's 2 times minus 45, so that's negative 90. All right, so obviously I'm not going to draw this to scale. Negative 90 would be off the page. So let me just put it down here. Let's suppose that's negative 90 over there. And that would be our intercept. All right, so let's start weaving the graph in between the x-intercepts. And starting up here, we'll go down to 5. And let's head up to 3. And let's remember that this is just a touching point because of that multiplicity 2, that even multiplicity. All right, so now let's go on and go down to the y-intercept and come up to this x-intercept of minus 1 and end it off continuing going up to infinity. All right, let's start number 8. Actually, I want to write y equal minus x cubed plus 4x squared. And let's start by factoring this. We can factor out a negative x squared. So here we're left with x. And here we're left with minus 4. Okay, make sure if you multiply that back, you have minus x cubed, and here we have plus 4x squared. Okay, so we have x equals 0 is an x-intercept, and x equals 4. So those are both x-intercepts. The y-intercept is also y equals 0. 0, 0 is an x and y-intercept. All right, so let's put our intercepts on the number line. We just have 2 of them, 0 and 4. And x equals 0 is a touching point because of this multiplicity 2. So I'm going to circle that just as a reminder. All right, now let's look at the end behavior. So this is the highest order term, the highest degree, minus x cubed. So minus x cubed, when x goes to infinity, that's going to go to minus infinity on the right. And when x goes to minus infinity, this is going to go to positive infinity on the left. Okay, again, x goes to minus infinity, so this is heading to minus infinity, and this negative in front would make it go to positive infinity. So that's how I'm going to indicate the end behavior. All right, and now we're ready to just connect these arrows. So we're going to start down this time, start down below the x-axis, and we're going to go through the 4. Okay, let me do that. Let me just head this through the 4, go through that intercept, And here we're going to go head down to this intercept at 0, but we're not going to go through the x-axis. We're just going to touch here and then continue going up on the left. So that's our approximate graph. Okay, number 9, I left off equal y. Let me put that in. All right, so first we'll factor. So let's do that. Let's pull out minus 2x. All right, so here we're left with x squared minus 25. And we can factor that further, so that's minus 2x, x plus 5, x minus 5. So we have, for our x-intercepts, we have 0, minus 5 coming from the second factor, and 5 coming from the third factor. Let's put these on the number line. So we're putting 0, minus 5, and 5. Now let's look at the end behavior. Here's the leading term, minus 2x squared. Sorry, minus 2x cubed. When x goes to infinity, as x goes to infinity, this is going to negative infinity because of this negative sign in front. So that would mean down on the right. And on the left, as x goes to minus infinity, this is heading towards minus infinity because of the odd exponent, minus infinity, and we have this minus in front. So it's going to go up to positive infinity on the left. So up on the left, down on the right, up on the left. We don't have any zeros of higher multiplicities. It's all multiplicity 1. So the graph is going to cross at all these points. So we're just going to weave around the x-intercepts. So we're just going to go through 5, and then we have to come back down and go through 0, and we're going to head back up and come through minus 5. And that's our approximate graph.